Hello, today we are going to be learning about inscribed angle. An inscribed angle has its vertex on the circle. So here it is, right here. Here's your vertex at angle B. This is your angle. And of course we can call this angle a couple different things. One is angle B, name it for its vertex, or ABC, vertex in the middle. Just remember those things. Okay, so now what we want to do is know what's the relationship between the angle and this right here. This is called the intercepted arc. So for this angle right here, it's like it cuts this piece of the circle out. So this arc right here is kind of cut out with the angle. And if we say that that is 100 degrees, then the little equation over here will help you. The angle equals 1/2 the intercepted arc. If we know that the arc is 100, then half of the arc, half of 100 is 50, the angle is 50 degrees. And that's the relationship between these two measures. If you knew the angle was 50, then you would double it to get the arc. Okay, so moving on to these couple of special situations down the bottom on the left. So here we have an angle that's inscribed in a semicircle. I look at this picture, the first thing I see is this diameter. As soon as you see this chord or this line, this segment going through the center, it's a diameter, and that tells you that you have a semicircle of 180 degrees. Also, this piece up around the top is 180 degrees, but here's one angle, right? So here's angle Y right here. And angle Y, if we kind of trace it, we see that it cuts out this piece of the circle. That's kind of what it's eating, 180 degrees. So remember, from above, we take our arc, divide it by 2, so we cut it in half, and that's going to be this angle in here, and it's 90 degrees, so that's why we have the right angle. This example here is my go-to example. If you can't remember which way to multiply or divide by a half, this is the example that tells you. Once you have a diameter, we know we have this 180 degree arc. So that's your 180 degree arc. And to get inside to here, which is 90 degrees, we have to divide by 2. Given this angle, multiply by 2 to get the arc. Memorize this example and work everything else off of that. This guy over here on the right. Okay, so in a circle. So here we have in a circle, they're talking about angle C and angle D. I want to use markers, but here's what happened. So I used markers on the top, but on the back it bled through. So I'm not going to use markers anymore. And I'm just going to do my best to trace these two angles. So angle C is here. And angle C cuts out this piece of the circle. That's arc AB. Now I have angle D. And angle D is here. And angle D, well, it also cuts out the same piece of the circle. So because we have inscribed angles that intercept the same arc, this is the same arc, these two angles are congruent. Well, it's always easier to throw out numbers so we can see an example. Let's say, just so we see this all happening, that this arc AB is 60 degrees. If this arc is 60 degrees and I want to come back in here to angle C, well, let's look over here, right? Arc to the angle, I have to divide by 2. So if that's 60, well, this guy in here would be 30. And then if I want to come into angle D, well, the arc is 60, so coming in here, yeah, that's going to be 30 also. and they are the same. And I found them the same way, so this 60 could be any number at all. We just threw out 60 because it's kind of nice. That's it. Okay, let's look at these on the back. Sorry that it bled through. Moving on. So let's see how many of these that we can do. Okay, so if this arc down here is 82, then to get over here, we are going to divide. So that is equal to 41 degrees. Jumping over to number 2. Okay, so hopefully we can see everything from now on. I'm going to write in everything they tell me. AC, that's this guy over here. Arc AC is 120 degrees. Angle B. B is this inscribed angle, and remember arc to angle, cut it in half. And here's angle O. We didn't talk about this one yet today. This is from last week. This is a central angle, and the central angle and the arc are the same. Very important that we know this. I think there's one like this on the little assignment that you guys have to do, so make sure you know how to do that one. Let's see, B you said was 60 degrees, and this one we said was 120 degrees. Let's move on to number 3. Okay, so number 3, we want to find the measure of angle D. Here's angle D in here, and O. O is over here. And all they tell me is 52. That's an inscribed angle. So I can trace the angle with my pencil, and here is the arc. And the arc is twice, so that's 104. Remember your central angle, we just went over it, the central angle is 104. Here's angle D, and I'm going to trace angle D, and I see that it's the same arc, divide by 2, so there's 52. And yeah, these guys, remember that theorem, it said they were going to be the same. So angle D is 52 degrees, and angle O is 104 degrees. Moving on over here, number 4. We want to know what angle P is. Well, if I look here, the only number they give me is the 55, so I have to use it. I'm going to trace angle M, and that's this arc here. I'm also going to trace angle P, and that's the same arc. Well, just like this guy, if it's the same arc, well then it must be 55. I didn't even have to do anything. So here's 55 degrees. Oh look, I get really excited for nothing because they actually do want arc LN, which is times 2, 110. Okay, number 5. Of course, they have to complicate things. Arc DC, well that's this one down here. We're going to figure out what that is, and we're going to add that to AB. Well, that's not bad because they told me that one. It's 76. But I have to find this. If that angle's 45 times 2, this guy's 90. 90 and 76, I can do without a calculator, right? 166. Number 6. Okay, this is a good one. Start it. This is going to be on the assessment also, on the quizzes. Okay, this angle here, I'm going to trace it. Trace this out here and out there. Here's this arc. And now I'm going to trace this guy here and this guy here, and look, it's the same piece. And since it's the same piece, that means that the angles are the same. I'm going to slide this up a little bit, sorry it keeps moving, and I'm going to set these two guys equal to each other because they have the same intercepted arc. 6x minus 11 equals 3x plus 7 minus 3x, oops, plus 11, and x is equal to 6. That's what they wanted was x, right? Yep. Number 7. Okay, so here is number 7. Oh, look at your picture. Hopefully when you look at this picture, you see a diameter. There are no numbers in here, but they give you a diameter which tells you that you have a semicircle of 180 degrees. They're referring to angle A, and here is angle A, and A's intercepted arc is that 180 degrees, and this is one of those special rules and one of those special cases. Divide by 2, we saw that that's a right angle. It's 90 degrees, so I know that 6x is equal to 90 degrees. Divide by 6, and x is equal to 15. Then I come over here to the last one, and I see a diameter again. So the diameter is the first thing I'm seeing. Already I'm thinking 180 degrees, but actually they're not even looking for that because they just want the measure of arc AC, and here's AC. So I'm going to trace it, and the only number they give me is 55, so I'm going to trace my 55 and see that that arc is the intercepted arc. So times 2, this is 110. They could have asked you for a bunch of things. They could have asked you for angle C. Well, you know that it's a right angle. If this is 110, it's sitting in a semicircle, you know over here that's 70 degrees. You could even take this arc over here and jump inside here to A and make that 35. And look, 35, 55, and 90, yeah, that makes 180 degrees for a triangle. So there's lots of different things that they can do here for questions, but that is where we are going to start.